Let's take a look at our next problem, the chemical reaction problem. In the chemical reaction problem, they give us an initial condition when t equals 0. We have 10 grams of the substance. They also give us the differential equation. It's already solved for us. One thing I want to point out with this one is that when we look at this differential equation, you'll notice that it is not a dp dt equals kp. In other words, it's not a direct proportional to that population. It's directly proportional to the square of whatever y is. So since this is squared, we can't jump to that equation that we have been using in our previous ones. Let's go ahead and look at Part A. In Part A, it says let's use a line tangent to the graph. In other words, it's all the way back to Chapter 3 when we did tangent line equations. The line tangent is going to be based upon f prime of A equals f prime of A times x minus A plus f of A. Again, using that initial condition, in other words, when t was 0, and when t was 0, we had a y value, or f of 0, is 10. So we're going to substitute that into this equation here, and when we solve that, square the 10, multiply that, this will give us -2. That's our f prime that we're solving for. Okay, so our equation now, given what we have here, will be y equals this -2 times x minus 0 plus our 10, or y equals -2t plus 10. This asks us to use that to find out what amount of substance will be in there when t equals 2. So we'll get y of 2 will equal -2 times 2 plus 10. -2 times 2 gives us -4, plus 10 gives us 6. So f of 2 will be approximately 6 grams. Okay. Let's take a look at our Part B. In Part B, it says use the differential equation, determine whether the graph this graph could resemble what we have over here. So if we look at the graph, you can see that the graph kind of goes up and then down. In other words, it looks like we are concave up here and then concave down there. So when I see this question, could this differential equation match this? I'm thinking to myself, well, let's just check the concavity. To check concavity, we know that concavity is not based upon dy dt, but it's based upon our second derivative. So let's go ahead and take the second derivative of this and check this out. You'll see that this will be a -0.04 times y dy dt. We can go ahead and substitute in for dy dt and do a little multiplying here, and -0.02 times -0.04 will give us a positive 0.0008. Y times y squared will give us y cubed. So will this match this? Well, now that I look at that graph, you'll see that all of these have positive values for y. So if y is greater than or equal to 0, then dy, the second derivative of our function, has to be greater than 0. Looking at this, that's fine here, but it's not going to match the graph when we are concave down. So we're going to have to say, no, this does not represent this graph because of the concavity that we see. Let's take a look at Part C. It says find an expression for f of t by solving the differential equation with the initial conditions. So we're going to go ahead and solve this. So Of course, first thing we're going to need to do is get our y's to the other side. So this will be a y to the negative second dy equals negative 0.02 dt. Everything is separated. We can go ahead and take our antiderivative, add 1, multiply by the reciprocal, and this is just a 0.2 times t plus c. Go ahead and check out our initial conditions. That initial condition was what they told us of f of 0 equals 10. So let's go ahead and substitute that in. This will be a negative 1 over 10. That's our function here. Will equal, well, this is just going to be 0. That's just going to be what c is. So our differential equation will be, based upon this, we can change this now to negative y to the negative first power equals negative 0.02 t minus 1/10. Okay. I think what I'm going to do is go ahead and change the signs here, multiply everything by negative 1, and now everything actually becomes positive. 0.02 t plus 1/10 is what we have on this side. And then, of course, if this is y to the negative first, or 1 over y, all I have to do is take the reciprocal of everything. This will be a y equals 1 over, in this case, this is tenths, hundredths, it's 2 1/100ths, or 1/50th of t plus 1/10 of t. To get rid of our denominator, multiply everything by 50. 50 times 1 is 50. 50 times 1/50 of t would give us t. 50 times 1/10 would give us plus 5, and that is our equation. Now, the last thing it mentions here, or asks us to check on, is determine whether the amount of substance is changing at an increasing or a decreasing rate, and then explain your answer. Okay? Well, it all goes back to our second derivative here. That tells us how the rate is increasing or decreasing. And the same thing goes, what we said before, that this is always going to be a positive amount. Therefore, the substance is always increasing, because the rate of change of the substance is always going to be a positive. So we're always going to have an increasing rate of change. Or in other words, dy dt, the slope of dy dt is always going to be positive. It's always going to have a positive slope.